Problem 64. Using electronegativity values, classify the bond formed between each pair of elements as polar covalent or ionic. So which one is it? Polar covalent or ionic? Now the electronegativity values we can get from that figure 4.4. Okay, so for each element, here are the electronegativity values. And then using table 4.3, we can classify the bond. So let's first assign or just write down the electronegativity values for the elements in here, and I've copied them down below. So nitrogen and oxygen would be A. So nitrogen and oxygen. Find them over here. Nitrogen is 3, oxygen is 3.5. So that would be 3 and then 3.5. And the difference here, we'll need the difference. The difference is 0.5. Okay, so if you take the larger one minus the smaller one, that would be a difference of 0.5. How about oxygen and hydrogen? Hydrogen is 2.1, oxygen's 3.5. So 2.1 and then 3.5. The difference this time is 1.4. 1.4. And then let's do sulfur and chlorine. Sulfur is 2.5, chlorine's 3.0. So 2.5 and 3.0, a difference of 0.5 again. And then the last one would be the sodium and chlorine. Sodium is 0.9 and chlorine is 3. So 0.9 and 3. Okay, and that's a difference of 2.1. Okay, now that we have the electronegativity values and their differences calculated, we use table 4.3 to classify the bond. So imagine these atoms are all bonded together. Nitrogen is bonded to oxygen, oxygen's bonded to hydrogen, and so on. What this table tells us is that look at the difference between the electronegativity values of the elements. If the difference is less than 5, the bond is nonpolar. And these shared pair of electrons in the covalent bond would not be pulled anywhere. If the difference is between 0.5 and 1.9, then the bond is polar and the electrons are pulled towards the more electronegative element. So here, this one is, starting at A, this one is 0.5, so that falls in the polar region. And the electrons are being pulled towards the more electronegative elements. And so that's towards the oxygen. We'll draw the arrow that way. And so the electrons are pulled in that direction. This would be the negative part, the negative side of the bond, and this would be the positive side of the bond. You say it's partially negative. It's got, the electrons are kind of tilted towards the oxygen, and this one's partially positive. And so let's write this one down. This is polar covalent, and the electrons are pulled towards the oxygen. Okay, how about oxygen, hydrogen? The difference is 1.4. That, again, falls in the polar covalent region. This time the electrons are pulled towards the oxygen because it's greater. So the dipole, as it's called, that dipole this time points towards the oxygen. So again, another polar covalent bond. The electrons are tilted towards this end of the bond this time. Sulfur and chlorine, the electronegativity values here, the difference is 0.5. That falls into the polar covalent region again. And the dipole this time is pointing towards the chlorine. Chlorine is pulling the electrons away from the sulfur. Another polar covalent bond. And then looking at sodium and chlorine, chlorine's much more electronegative than sodium. The difference is 2.1 this time. And so this is an ionic bond. And when the difference is greater than 1.9, we say that the electrons aren't just tilted towards the chlorine. They kind of have moved all the way over there. And so that's what, we could say this is a full-on negative ion this time. And sodium is a positive ion. So there is kind of like a spectrum, between polar, ionic, and nonpolar, but hopefully you get a better understanding now.